Hi, my name is Mrs. O'Reilly, and I'm here to give you a short video on sources and uses of water, with some information about the water cycle as well. Do we have enough water in the United States? There's approximately 4 trillion gallons of rain, sleet, and snowfall per day in the entire United States. Humans use 10% of that precipitation, but what happens to the other 90%? The water cycle is important in understanding this. It's Earth's way of cleaning the water. Water is in many forms on the Earth. It's solid and ice, liquid, gas. Where is this found? Yes, you're right. You can see the gas rising off of lakes and streams in the early morning when you can see that water evaporating. It's also on a steamy day or in fog, there's water suspended in the air. Water moves in and out of these states as well as through living things. How does water move through us? When it moves between states, we have certain terms that we use for this. So as you remember, melting is from solid to liquid, freezing is from liquid to solid. Those are opposite processes. 2 more opposite processes are condensing or condensation and evaporating. This is between gas and liquid. And the terms used to go between a solid and a gas are subliming and depositing. And here's a graphic to help you with that. The water cycle uses these terms where there's precipitation when the gas water condenses in the sky and falls to the ground. So we would see this as rain, sleet, snow, hail, etc. There's transpiration. That's when water evaporates off of the plants. You can see that happening here. There's also surface runoff. Surface runoff is how after the water or the precipitation, however form it takes, runs off, typically as water, and it moves from a high to a low surface. So gravity is allowing that water to move to a lake and then maybe down a river into the ocean or into a reservoir instead of a lake. And then there's percolation. This is when the liquid water is absorbed into the ground. Let's see, where is that here? Percolation is here. So that's when the liquid water is absorbed into the ground to be stored in aquifers, and that's underground water storage. So what happens to all the water? Precipitation is mostly rain, but obviously we know of other types like snow. It goes to 2 places. It either can go into groundwater or surface water. Groundwater is that percolation when it soaks into the ground, and surface water is brooks, rivers, lakes, oceans, wherever you see a body of water. The surface water is then heated by the sun. It evaporates, cools down, and then falls again as precipitation, hence the cycle. The cycle is continuous. It keeps on repeating. So think about it. A dinosaur could have walked through the water that you're drinking now. Think about where would you expect the water to be the dirtiest? That's right, in the runoff, after it's collected all those things as it traveled from a high to a low area. Where would the water be the purest? Yes, as it evaporates, because only water, only H2O is evaporating off of that surface. So why is water important? Well, we as humans need about 2 liters of water. It's lost each day through evaporation or excretion, which would be when you use the restroom. And this water must be replaced. A person can live 50 to 60 days without food, but can only live 5 to 10 days without water. How long would you live without air? What do we use water for? Well, in some cases, it's direct use where you can see the water being used. We drink it, we water our lawns, we wash our cars. But in some cases, you don't see that water being used. We call those indirect uses. This is when we produce food, manufacture cars, grow a Christmas tree, or produce the meat for a hamburger. And there's a bunch of other foods and products that we use here that water goes into that production. So if there's enough water, what's the problem? Well, the water's not necessarily where we need it. Where is all the water? Well, if you look at the total global water, 97.5% of that water is salt water. We can't drink salt water, and it's not yet practical for us to create fresh water from salt water. There are processes for that, but it's not yet practical to use on a large scale. It's not worth it. Then you look at this amount here. If I take this small 2.5% and move it over here and look just at that 2.5% of the global, that's the fresh water. Well, most of that is found in glaciers and permanent snow cover. Also not usable. About 30% of that is found as fresh groundwater. There's some others, that's soil moisture, swamp water, and permafrost. And the last bit is freshwater lakes and river storage. And only this portion here, this red sliver here, so this little red sliver out of all the global water is actually renewable. So our water comes from either surface water or groundwater. Surface water, you follow the blue here, can go to public water supply, domestic use, that'd be your home, irrigation, and livestock. It can also go into aquaculture, industrial, mining, and thermoelectric. Groundwater can be used for a lot of the same things. And you notice the amounts that are listed here are showing you which one is more common or more used for that purpose. And this is for the United States. So where does your water come from? Well, if you have a well, your water comes from groundwater. About 20% of the USA's water is groundwater. This is stored in aquifers, which I've used that term before, but it's a porous rock, meaning it's a rock with little tiny holes in it, kind of like a sponge is porous. It holds millions of gallons of water for thousands of years. You might also have surface water. Reservoir, lakes, and rivers are considered surface water. All of these sources are typically treated by the town or an individual before entering your tap. Are these sources of water totally pure? Meaning, is there only H2O in them? No. They contain many dissolved minerals, gases, etc. And these can be important for us and nutrients for us. But in some cases, it's not good for us. And we're going to be talking about that later. When did the availability of water become a problem? Well, early humans used local streams, but as populations increased, so did sewage, and then bacteria, and then diseases. So we ended up with lots of cholera and typhus and other diseases. So now we treat our water. Over the foreseeable future, is this problem going to get better or worse? So let's take a look at what goes into water treatment.
New York City has 14 wastewater treatment plants. In total, we treat about 1.3 billion gallons per day. There are about 8.5 million people in New York City. All of their wastewater is treated at one of the 14 plants. Here at Newtown Creek, the service area is about 1.1 million people. This plant here at Newtown Creek, though, is the largest of the 14 plants. It treats, on average, about 225 million gallons a day. We receive sewage from parts of Brooklyn, a little bit of Queens, and actually almost the entire east side of Manhattan and lower Manhattan. We're right now at the lowest level of the facility, about 50 feet below street level, where the raw, untreated sewage enters the plant. We have the sewage pass through a series of metal bars that are spaced about 1 inch apart, and those bars remove anything that may get into the sewer system that could clog up pumps or other equipment. A lot of the material we do see are sanitary wipes, which, unlike toilet paper, really don't break down in the sewer system. So occasionally things wash up on the screens that shouldn't be in sewer systems. Fish, we get turtles, we get dollar bills from time to time. A few years ago, there was a firearm that came onto the screens. NYPD got involved with that. A lot of things that are in sewage can't be physically or mechanically removed. They have to be removed in other methods. So we remove that material here at what are called the aeration tanks. And in these tanks, we cultivate microorganisms that are naturally occurring, and they actually consume organic material that's in sewage, and that's part of what we call the biological treatment process here at the plant. We're now at a part of the process called the final settling tanks. Organic material that has now been consumed by microbes is heavy enough where it can settle to the bottom of these tanks and be physically removed for later processing. Obviously, treating sewage from 1 million people can be odorous, so we do a lot of odor control here at this plant. All of the tanks are essentially covered where there can be odors, and that odorous air that are trapped under the covers passes through activated charcoal, which removes a lot of the odor-causing materials. The organic material that we remove from the wastewater is called sewage sludge, and we now have a couple of processes for that material. One of them is called thickening. We're at the top of one of the 8 egg-shaped digesters here at the plant. We're about 140 feet in the air. It gives you a good view of the city. The purpose of digestion is fairly simple. We want to take the organic material that's in the sewage sludge, fats, proteins, carbohydrates, and break them down into more basic components like carbon dioxide, water vapor, and methane gas. And that's done here in these digesters. So as you see here, this is the last step in the process. We've added bleach to the wastewater, and it's leaving the plant at this point and going down to an outfall that releases the treated sewage into the East River. There are federal regulations that require all wastewater treatment plants in the country to remove at least 85% of the organic material that comes into a plant. This plant generally removes between 92 and 95% of the material, so we do better than federal standards.
So I hope you enjoyed learning all about how New York City handles their sewage. A visual for this is what a total trip system layout might look like. Obviously, this is not exactly what they all look like, but this is one layout. So you can kind of take a look at this and see how things can water gets treated and then ultimately can go into an irrigation system in this example. So since we don't have a lot of usable water, something to think about is to play your part and be water smart, which I know sounds really cheesy, but just here's a bunch of ideas on wise water use, things that can make you a little bit more aware of how much water you're using on a regular basis. And if you can do without using water in a certain scenario, then you should, and you can be more mindful of it. So I hope you enjoyed learning about the water uses and water sources. And if you have any questions, let me know.